The astronauts, a record 8 number of them, include Americans, West Germans, and a Dutchman. CNN will bring you the liftoff at noon Eastern Time, about 9 a.m. Pacific Time, if it's on time.
It's been retracted, and it is sitting there ready to be fired.
You can see the beanie cap, what they call the beanie cap, moving away. That's a structure which keeps the ice from forming on the top of the tank. The APUs have been initiated. That controls the flight surfaces.
The largest crew in space history, as far as the Americans are concerned, entered the orbiter about 2.5 hours ago. 8-person crew, both from the United States, from Germany, and one Dutch astronaut from Holland that are going on this 7-day Spacelab mission. It's going to be an extremely busy time in the 7 days they have up there. They will work on 76 experiments in the time they're up there, hopefully gathering a lot of data.
And uniquely on this mission, the payload will be controlled from Germany. The shuttle from Houston, the payload from Germany, Oberpfaffenhofen, which is near Munich, Germany. This mission will concentrate on microgravity, which we'll talk a lot about over the next week, doing both materials processing and life sciences studies in the space environment in which there's very low gravity.
All right, we're at the auto sequence start, so they have less than 30 seconds now before the launch. Let's listen into mission control.
We'll soon be arming the SRB ignition, hold down post, and T0 umbilical ordnance. Minus 13 seconds. Minus 10. We're go for main engine start. 5, 4, 3, 2, 1. We have ignition and liftoff. Liftoff of Challenger and the Spacelab D-1 mission. And the shuttle has cleared the tower.
Houston controlling now. Roll program initiated. This 102-degree roll puts the ship in the proper attitude for flight downrange on the 57-degree inclination. Wings level.
Challenger Houston, the cryo H2 pressure is a deucer.
Roger, thank you. We're throttling down now for limitation of dynamic pressures on the ship as we pass through the sound barrier.
The picture you're seeing is from some special long-range cameras that NASA has at the Kennedy Space Center that enable you to see basically up to about 50 miles away.
Yeah, we'll actually get to see the separation of the solid rockets, which takes place a couple of minutes after launch. The main thrust here is coming from the solid rockets. They're the white rockets on the side of the tank. 5 million pounds of thrust total out of those 2 rockets.
And these rockets will be separating from Challenger in just a few moments, and they will be on their own power then, continuing on into their orbit.
That's right. Once the solids separate, then you get liquid fuel from the tank. So they've passed through the region of maximum pressure. They're throttling back up the main engines again.
Downrange 8 nautical miles, altitude 11 miles.
8 miles downrange now, and still have a pretty good close-up picture.
APUs running smoothly.
This trajectory carries them right up the east coast of the U.S.
Engines performing nominally.
Probably seeing a little more cloud cover on this launch because of the after effects of what was Hurricane Juan and is now Tropical Storm.
Standing by now for the call of PC less than 50, which is a precursor to solid motor separation. PC less than 50, Houston.
Roger, PC less than 50.
Okay, they've said that the pressure in the chamber of the solid rockets is low enough. Now they're separated.
We copy 7.
They fall away. They have parachutes in the nose. They'll be recovered later on. Fantastic picture there.
Guidance has converged as programmed, 2 minutes, 20 seconds into the flight.
A couple of missions ago, we had a problem just after this point where one of the shuttle's main engines shut down.
Right, there was running a high temperature in one of the pumps, and the engine shut down.
Subsequent calls will be on time. Altitude.
The main engines now should run for another 6 or 7 minutes.
7 miles. Velocity 5,000.
Fantastic picture there of the 2 solids falling away from the vehicle.
The 2 white dots you see in the center of your screen.
Which will be 2-engine tower.
Houston, 2-engine tower capability.
They call on time, advising the crew that if one main engine should fail, we could still make the transatlantic abort site at Zaragoza on 2
again.
Right. You see the sled, the rails coming down the middle of the module. Ernst Messerschmitt is sort of leaning into the racks there off to the right, and I believe it's Guy Bluford on the sled. They will run the sled in the 3 different directions. He'll sit sometimes upright, facing forward. Sometimes he'll face sideways, sitting upright, and in this position, lying down, to exercise the 3 different directions of the inner ear sensors, the vestibular organ.
It is a life science experiment that is also causing concern in another area, the possible health of Ernst Messerschmitt. The question was raised during a news conference from West Germany. We could only hear the audio from that, but the question was asked if he indeed passed out for 30 minutes yesterday after some of the medical experiments. The doctors in West Germany denied that this had taken place. I think what prompted this was a statement that Ernst Messerschmitt made himself yesterday, that he had trouble for about 30 minutes after he woke up, telling the difference between the floor and the ceiling inside the orbiter. So this may have prompted the question. Rick Chappell, what about his health?
Yeah, I think he's in fine shape. We noticed initially, there are just a few things you can sort of get an indication of how they're feeling. We noticed right after launch that Ernst was moving a little more slowly than perhaps some of the other crew members. No problem with him at all, just the immediate sort of adjustment to microgravity. Here you see Guy Bluford doing a measurement of Ernst's eye pressure using a little device called a tonometer. He's obviously fine. He did, as you say, go through a description of sort of how he felt when he woke up. And it was with the life sciences people and had to do with his perception of up and down after having been asleep in microgravity. But the medical people have said that there is no problem with Ernst whatsoever, and hasn't been.
We can see Ernst throughout the day in the cabin, and he seems to be doing well as most of the other astronauts do.
Yeah, here you see all 4 of 2 of the payload specialists, 2 mission specialists in the module. A lot of room in there. They're doing, in this case, they're doing some material sciences, they're doing some life sciences, and then doing some just regular housekeeping type activities.
We can report that all 76 experiments now aboard the Spacelab are operational. They used a new fuel pump and a new computer software program to start one of those furnaces that had not worked since they had taken off, so everything is now operational. You can see Ernst Messerschmitt going through the folders on the right-hand side of your picture, and doesn't appear to be having any problem of the serious nature that everyone was talking about.
Yeah, he's fine. We've listened to him all day, and he's just clicking things off, not having any trouble at all. One thing that they have just finished is that they had a faulty sensor in one of the ovens. They evacuate the oven when they do a particular sample melting, and they had a faulty sensor in there that was causing the computer to shut the experiment off continuously. What they did was actually bypass the sensor. They went in, disconnected the cable from the sensor, and they're running without it. And they have just commented that there is vacuum in the furnace, so everything's working fine in that regard.
The sled appears to be just sitting still. Have they started in any of the disorientation? Is this part of it where he is simply laying down on the sled? Are they taking readings at this point?
I think at this point they're just getting ready. They're setting up all the protocol, and then the computer runs the sled. It'll go through a series of motions back and forth down the module, different acceleration levels, different frequencies back and forth, and the camera will watch Guy's eye move as they do that, and he'll also report his feelings of movement. We should emphasize this is not an experiment to make Guy Bluford feel bad, but it's an experiment to actually watch his eye respond to this experiment into a crystal.
We have an example here of what kind of crystals they're going to be making.
Yeah, this is a model of a crystal lattice structure. What you see with this model is that there's a very regular formation of the different atoms. It would be used for ultraviolet, gamma ray, X-ray detection as an optical. It has this infrared camera, and it will actually watch the eye move. The eye will do what's called nystagmus, which means a twitch from side to side, or it can counter-roll, actually do a twist, and the camera will watch that. Or, in this case, they have electrodes around the eye that measure the electrical signals to the nerves around the eyes that also cause the eye to move. So you can either watch the eye or you can measure the electrical signal that causes the eye to move. Either way, you get information on how the brain is responding to the inner ear.
We seem to have lost our live picture momentarily. This is only one of 76 experiments that are being carried out on Challenger. We have another one that we have some videotape of. It's called the rotating dome experiments, a series of colored dots spin in front. This is a split camera view.
Another very interesting thing, the payload specialist looks into the dome, and then there's a camera on the far side of the dome that looks back at his eye. So on the right, you see the eye, and in fact, you can see the reflection of the dots going around in the dome in the pupil of his eye. The eye will actually track these dots, and the eye will twist actually around the direction looking straight forward. The eyeball will twist and try to track the dots. That's a normal response, and it happens using the brain determines that twist from both the visual information and from the inner ear. When you get into space, the inner ear information is not good anymore, and so the brain has only information from what the eye itself is seeing.
Is he wearing a special contact lens?
He has a contact lens on, which has some markings on it, so that it helps to see the twist of the eyeball.
What kind of sensation would you have in watching these rotating dots? One would think that would make you sick.
Well, it doesn't, but what happens is after you watch for a while, you begin to think you're rotating. And the key thing, once you put your head in this dome, the key thing that they measure is how soon does the subject begin to think that he's rotating instead of the dome is rotating. And they do this on the ground before they go into space, where the inner ear is giving good information. Then they do it in space, and there's a different time required.
We have our live pictures back again from Challenger in the German Spacelab, and it looks like the sled has stopped now, and they're preparing to line up possibly another portion of the experiment.
Right. What they do is once they get the subject set up, you see the other one payload specialist on the sled itself.
11 minutes past the hour. The Challenger astronauts are working at a frenetic pace to wrap up their experiments before landing tomorrow. CNN correspondent Tom Montier and NASA scientist Rick Chappell are with us once again today with details on the status of this current shuttle mission, and they're really hustling up there to get everything taken care of.
The 8 astronauts have vowed to finish everything before they return. They were possibly going to be extended one day, but that was yesterday. So it will be landing on schedule Wednesday, just before 1 o'clock in the afternoon Eastern Standard Time. And they're going back into the experiments now in preparation for landing that test why astronauts get sick in space.
That's right. They are using the sled, which moves the astronauts back and forth down the aisle of the module. You can see here the sled on the tracks. The tracks are coming toward, and now you see the sled moving. It's operated by the payload specialist at the other end there, who's in front of a console, and then either the mission specialist or the payload specialist rides.
It must be a strange sensation going back and forth like that in a weightless environment.
It is, and of course, what's happened is now for almost a week, they've had very little sensation of gravity in the inner ear. The inner ear is almost not functioning anymore, and now they will actually stimulate the inner ear with this linear acceleration.
The astronauts have been taking VIP phone calls the past couple of days and also a German news conference yesterday. Today, Franz Joseph Strauss, the Vice Chancellor of Germany, called up and talked to Guy Bluford for a few moments.
I would like to address you immediately, Dr. Bluford, and to tell you how interested we are, how fascinated we are, and I would like to express our thankful feelings for your great activities and your great achievement and your wonderful performance. Well, it's a real pleasure for me to be a part of this U.S.-German flight and to work with the German scientists and engineers as well as some German astronauts and trying to get a lot of this science done.
Another part of the science that they're doing on Spacelab is a series of blood tests. Here you see Bonnie Dunbar donating some blood to science in space.
This particular experiment looks at both the pressure within the blood system in the upper body, as well as the content of the blood. They actually draw blood, but there's also a little device that measures what's called the central venous pressure, which measures the shift of fluids to the upper body when you're in microgravity, different from on Earth where the blood tends to pool in the lower part of the body. So this device, which is fairly complex, has both the pressure measurement and then actually draws the blood, which they centrifuge down and freeze, and then they'll study later when they get back.
The science is drawing to a close in preparation for the planned landing at Edwards Air Force Base in California, somewhere over Lancaster, California.
Right, they're approaching the final landing circle now, or the landing cylinder. They have gone through a series of what they call S-turns, where they've used up the orbital energy, and they are now approaching this landing circle where they'll make a final turn onto their approach to the runway.
They're going to be making some S-turns with the shuttle to decrease their landing speed.
In fact, they did that. They have done that at like Mach 25, Mach 20, Mach 10. There's the sonic boom as the shuttle goes over. It's like when you're skiing and down a steep slope, when you rock back and forth and dissipate energy into the snow. They do the same thing as they come into the atmosphere. They make big rolls or S-turns and lose energy into the atmosphere.
There's also a test that's going to be conducted on landing. The steering system, the nose wheel steering system has been altered a little bit, a new system that they're going to use. They're going to go about 20 feet off the runway center line to test if the nose wheel steering works instead of using the brakes to attempt to steer the big space plane.
All right, they would like to be able to steer at higher ground speeds, and so they have adjusted the steering system over the way it was originally to be able to do this steering.
Because of the small nav error, the surface winds are calm, altimeter is still 3018, and viz is up to 7 miles plus.
Doesn't sound like the winds are going to be any problem.
That's right. It's a pretty day out there. They said there's some haze, but no clouds, as you can see.
About 2 minutes away from touchdown at Edwards Air Force Base in California. If the nose test is successful, the nose wheel steering test, they will begin sometime in December landing at the Kennedy Space Center. What advantages will that offer them?
Well, Gordon Fulton said yesterday they would do one more nose wheel test at Edwards, and then they would start coming into Kennedy if that looks good. It's to a great advantage. Of course, it saves the trouble and time of having to load the orbiter onto the 747 and fly it across the country, which takes a couple of days to do. And also, if you're doing experiments like they are here, where they're testing the adaptation of the inner ear to microgravity and then back again, it helps to land at Kennedy because they have an entire laboratory there at Kennedy to do the experiments in.
7 hours after touchdown, 5 of the shuttle's astronauts will be taking a flight back to the Kennedy Space Center, where they will be spending the next 2 weeks going through a series of medical tests, basically the same tests they performed in outer space, and they will be repeated on the ground to match the results.
That's right, and of course you'd like to do those tests beginning as quickly as you can because the adaptation takes place very rapidly.
All right, the shuttle is now coming up on the end of the runway, very steep glide path. Let's listen in as the last few seconds of the mission take away.
About 1 minute and 5 seconds away from touchdown.
Challenger Houston, we show you on glide slope on center line. Surface winds are calm. Roger.
They're at an approach angle of about 19 degrees. That compares with only a few degrees in a normal airliner, so they're coming down pretty fast at this stage.
I've seen pictures inside the shuttle as you come up on the runway, and it looks like you're dive bombing straight down into the end of it.
That's right. They've got now good microwave type contact with the runway that's giving them information on their velocity and their altitude. They're matching that with displays on board that have the predicted velocity and altitude, and Henry Hartsfield will bring it on down, and in just a few seconds will flare the spacecraft nose upward, or in this case the airplane nose upward, to lose the final speed and then come down.
Final pre-flare. Landing gear should be coming down. There they are.
They're now at about 250 miles per hour. Looks like we'll have to see a replay to tell whether exactly how far he steered off the center line. It's hard to see from this angle.
He was supposed to steer 20 feet in either direction as part of this test.
Very nice landing.
So as Space Shuttle Challenger rolls to a stop, it marks an end of the 22nd shuttle mission for the United States. Inside the orbiter is the German Spacelab, and all of the experiments tucked away. 75 experiments completed in the past 7 days. They will, of course, be unloading and analyzing that data for days, weeks, even months to come before they fully understand.
This is now continuing the series of Spacelab flights. So we've learned from in this case, particularly from Spacelab 1, we've done a follow-up experiments. Now we get to do some more as this series continues in D2, and then some of the other missions like EOM-1, Spacelab coming up this year.
So the next mission is scheduled less than a month away, the 27th, the next scheduled mission for a space shuttle.